All right, everyone, let's get the show started. Welcome to Office Hours. It's January 22nd, 2020. My name is Eric Osterman, and I'll be leading the conversation. I'm the CEO and founder of Cloud Posse. We are a DevOps accelerator. We help startups own their infrastructure in record time by building it for you and then showing you the ropes. For those of you new to the call, the format of this call is very informal. My goal is to get your questions answered. Feel free to unmute yourself anytime if you want to jump in and participate. Excuse my dog, he's having a fun time downstairs here. We host these calls every week. We'll automatically post a video recording of this session to the Office Hours channel, as well as follow up with an email so you can share it with your team. If you want to share something in private, just ask, and we'll temporarily suspend the recording. With that said, let's kick it off. Here's the agenda for today, some talking points that we can cover just to get the conversation started. One of the announcements for all of us using EKS, which is pretty good, is that the master nodes have now come down in cost. I believe it's a 50% reduction across the board. Again, this is only on the cluster itself. Like the master nodes, it has no bearing on your worker nodes themselves. So there's a link to that. The other good news is Terraform docs has finally come out of pre-release, and they have an official 8.0 release. It's actually up to 8.1 already this morning that supports HCL2. If your team isn't automatically using Terraform docs, I highly recommend it. It's a great way to generate markdown documentation for all your Terraform code automatically. Some people use pre-commit hooks. We have our own README generator that we use it for. Other people use it to validate that your inputs have been set, descriptions and stuff like that. Also, we launched our references section. This is, if you go to cloudposse.com/references, this is links to articles and blog posts around the web that have been written about how to use some of our stuff, since I think it's interesting to see how others have come to use our modules. This is a great resource for that. And the first technical topic of the day that I'd like to talk about, if there are no other questions, would be using Open Policy Agent with Terraform. And then I'm also curious about first-hand accounts using Jenkins X. So with that said, let's kick this off. Any questions?
Are you sharing the right screen?
Oh my God! I did not share my screen. All right, let's do that. Hold on. All right, let's see here. Share. I am not sharing the right screen. You see my notes. All right, the magic is gone. All right, share this window.
There you go.
All right, thanks, Andrew. There we go. All right, well, if no other questions, I want to share a status update on behalf of Brian Tai. He was the guy over at Audit Board or Socks Hub that had the challenge with those random Kubernetes nodes getting rebooted. Well, he finally got to the bottom of it, and everything else he did to try and triage it was beneficial, but wasn't actually related to the problem. So they rely on, oh shoot, not Datadog. What's that monitoring tool? Started off as an open source project, tracking all the traffic in your cluster. Andrew, help me out here.
Sorry, what?
Sysdig. Yeah, I think Sysdig is what they're using. So Sysdig for monitoring. So they have Sysdig installed on all their nodes in the cluster, and he was finally able to find the stack trace that was getting thrown by going to the AWS web console and looking at the terminal output of one of the nodes that had rebooted. We thought we'd actually done this. We forgot to actually do it. So this is where the actual exception was finally caught. The problem was a null pointer exception in Sysdig running on their nodes that was causing the nodes to crash. So it was actually their monitoring platform itself a SaaS platform, albeit nonetheless, that was causing it to crash. So they got that fixed, and now their nodes are not crashing anymore.
I have a cluster that some people spun up that they just kind of gave everyone access to it. Like, you know, this is just kind of a playground, whatever.
Okay.
And which in theory sounds nice, but what's happening is people are not being, you know, good stewards of using the cluster properly and setting resource limits and requests and everything. And so it's causing like CPU starvation on the nodes.
Mm-hmm.
And it's causing not just the one team to have issues, but like anyone using the cluster to have issues. And everyone's going, what's going on with the cluster? My stuff's not, I don't think my stuff is hurting the cluster.
Yeah.
And it's everyone pointing fingers at each other,
Right.
and that's all it's turning into. It's just a giant.
So what are your
about
thoughts on how to resolve that?
Don't do that.
Well, yeah, but I agree that it should everyone should play fairly with each other, but maybe there are some pretty simple things to do, like
don't give anyone cluster admin, and if a team wants to use the cluster as a sandbox, create a namespace. Yeah. Create a service account for that namespace that has, you know, whatever access to that namespace they want. Create a limit range on that namespace so that if they don't set a, you know, request or a limit, that it sets a default. And then they don't have access to the entire cluster. They just have access to the namespace itself, you know, and we get people bitching about, well, oh, I need to set, you know, I need to set a cluster role or whatever. It's like, well, go spin up your own cluster then.
Yeah, okay, I agree with that. That was basically going to be my recommendation, exactly what you said there. The only other augmentation to that, but I think it's going to take more effort, would also be to deploy something like one of these open policy based agent solutions that require limits to be set, that require all these things. Now for the roles, that can kind of be solved perhaps if you have GitOps related to this cluster, where you can add the roles, but that has to go through this different process, right? Anything that is global for the cluster.
Well, the next cluster is going to be, no one has access to it. And if they want something in the cluster, it goes through CICD, like Jenkins or whatever.
Okay, gotcha.
You know, so they register, you know, so they say, I have this app, you know, I'm going to push up new images to this container registry, you know, and then set up Harness or Flux or Argo or whatever on the other end, you know, and it requires kind of an ops team, you know, which is not super DevOpsy, but at the same time, it's like, if I give access to the cluster to everyone, it's just going to cause tons of problems. So, like, yes, I have an ops team and you are the dev team, but like, I want you to come work with me to set up your Argo stuff, and then we'll be in communication on Slack, and, you know, we can join each other's stand-ups or whatever, you know, and do that for, you know, DevOps collaboration versus here's access to the cluster, do whatever you want.
It's a free-for-all.
Screw the consequences.
Yeah. So one of the things you said just jogged the memory. I met with Marcin. He's a founder of Spacelift. I shared it in the Suite Ops earlier this week. And what I thought was pretty neat with what he's doing is two things that come from experience doing GitOps. One is addressing a big problem with Terraform Cloud. In Terraform Cloud, the problem is they don't provide a good way for you to bring your own tools. You have to bake those into your Git repo, and if you have like 200 Git repos that all depend on a provider, you have to like bake in 200 binaries and 200 repos, and yeah, no fun. Or if you like depend on other tools and you use like local exec provisioners and stuff like that, no fun way to do that with Terraform Cloud. So in Spacelift, he took a different approach. You can bring your own Docker container, kind of like what you have, Andrew, and what we have with Geodesic, with your tool chain in there. But the other thing that he does, and this is what jogged my memory with what you're saying, is sometimes you need escape hatches. Sometimes you need a way to run ad hoc commands, but we also want those to be auditable. An example is you mess up the Terraform state and you need to unlock, like the Terraform state is locked somehow. You need to run the force unlock command. How do you do that in an auditable way? The other example is you're running an actual real live environment and you need to refactor where your projects are, so you need to move resources between Terraform state. So you need to use the Terraform import command to do that. How do you do that in an auditable way? So what he's done is I forget what he calls it here. I think he calls it tasks, but he provides a way for you to run one-off tasks as part of your CI/CD. The other thing he supports, and this is a SaaS product right now, is you delegate roles to the SaaS, and then those roles allow this to run without hard-coded credentials, which is the big problem, right, with Terraform Cloud, is you got to hard-code your credentials everywhere. And Terraform, the open policy agent. So I posted a bunch of links this week in the Terraform channel related to the open policy agent. I confess it's been brought up several times before. Blaze, I know, has been doing some POCs on this, one of our community members. But it was Marcin showing me his demo how he's integrated into Spacelift using OPA that got me really excited. So I started doing some research on that, and then I saw it's actually pretty straightforward how you could integrate this into your CI/CD pipelines. So if you look at these two links here, I'll post them as well to the Office Hours channel. Let's see here. Oh, I know. I forgot to also announce that Office Hours has started here. Let me ping everyone that Office Hours has started. There you go. All right, so Office Hours. So there's the link to the open policy agent. So in here, they provide an example of basically how this works. So here's an example of like a typical resource that you would define in Terraform code. And then what you do is you basically generate the plan as JSON using this argument. And now you have this JSON plan. And then that makes it very easy to operate on the output of this in the open policy agent. So they have some examples down here of where you can now describe, where is it? Describe a policy for this. So here it has an example of looking over, of scanning over the plan. Let's see what this is. So number of deletions and resources of a given type. So here he's counting the resources. You could have, for example, a policy which is that, hey, if there are no deletions, reduce maybe the number of approvals that you need or something to get this PR through. So then someone else in the community posted a link to ConfTest, which seems even more rad because it adds support for lots of different languages or types. So it supports out-of-the-box JSON YAML, but also they have support for HCL2 experimental. So now you can actually do policy enforcement on your Terraform code using totally open source tools. So that should play well with like your Jenkins pipelines, CodeFresh pipelines, stuff like that. Andrew, have you given this a shot at all?
I am not able to do much experimentation and learning lately, and I'm frustrated about it. So no.
That's too bad. Carlos, this sounds like something might be up your alley, given the level of sensitivity of some of the things you do operating at a hedge fund. Carlos? It might be away from the mic.
I was muted. Yes, sounds very interesting. I haven't seen it until now.
Cool. Yeah, if you do a POC, let me know.
Will do.
I reposted those links into my company's Slack and my Terraform channel, and somebody said open source Sentinel is another one that they'd heard of.
Oh yeah, because Sentinel is HashiCorp's enterprise offering. So yeah, there's an open source Sentinel.
Maybe he was saying that what I was linking was open source Sentinel.
Yeah, and the equivalent of basically open source Sentinel.
Gotcha.
Exactly.
I hadn't heard of Sentinel. I didn't know.
Yeah, so Sentinel is an offering of Terraform Enterprise on-prem. I don't believe you can have it on the cloud version, the hosted SaaS version. I believe. I could be wrong.
Given the way that OPA has kind of created this standardized format for creating these policies using this language, it's called Rego, right?
Oh, is that the name of this syntax that we have here?
The OPA language is called Rego. Given the fact that OPA has created this standard, it's gonna have to be something super awesome nowadays for me to go with something that doesn't support OPA.
Yeah.
Like, I'm looking at Sentinel and it's going to be like this, proprietary thing that works, for this one aspect, and that's kind of it. Versus, what's the reason I went to Terraform in the beginning? Well, it's because it was standardized. Like, if I go AWS, Azure, GCP, whatever, it's all kind of, I can use Terraform. I don't have to learn some new tool.
Exactly.
OPA, I'm feeling, is that same kind of mentality now.
Yeah. Yeah, I think so. For kind of testing or validation of all these formats. And it's interesting for us because, let's face it, the tools that we use move bleedingly fast, and many of them lack sufficient validation on what they have or features. But now, like, let's say Helm file, for example, using this, it'd be very easy to express now some policies around Helm files, and some of your it's basically codifying your best practices now around Helm file. And doing the same for Dockerfile, etc. So yeah.
Like what?
So for Helm file, what would be a good best practice? That everything has the installable flag. That should be enforced in all of your Helm files. What else would be a good one? That you're pinning image tags or something. I'm struggling right now off the top of my head. I wasn't prepared for it. But yeah, I think we could find some things to validate in Helm files.
What's the installable flag?
Oh, so Helm file has moved in the direction of mirroring the interface of Terraform. So like Terraform has a plan phase and an apply phase. Now, in Terraform, the plan phase actually can generate a plan, and then you can execute that plan. In Helm file, it has something analogous to the plan, but not an artifact like a plan file. So what I'm referring to is Helm diff, right? So Helm diff shows you the potential changes without making those happen. Well, then Helm file has two other commands. One is apply, and the other is destroy. And those mirror Terraform. So the apply flag honors the installed flag. Versus sync, I don't believe sync. So when you run sync, I don't think it'll uninstall things. But apply will uninstall things. when you run Helm file.
Interesting. That's not what the documentation is saying, but maybe there's more.
Well, okay. I mean, let's get that right. I might be wrong. There is a nuance like that. Let's see what
the documentation is saying that the difference between apply and sync is that apply runs diff, and if diff shows that something is different, then it runs sync.
Mm.
Am I getting that right?
So yeah, apply. The Helm file apply subcommand begins by executing diff. If the diff finds that there are changes, sync is executed. Adding the interactive flag instructs Helm file to get your confirmation. Versus sync. Where's sync?
Sync says sync all resources from state file.
Yeah, it does. So I don't think it mentions it, and it doesn't look like it mentions it. So it doesn't mention anything about that installed flag, and I suspect before calling sync. I don't know. I could be wrong. Maybe it doesn't work that way. So ignore what I said. Maybe I am misled, or maybe the functionality has changed since we started using it. But the idea is that apply is intended to be used as part of your CI workflow.
We're getting into Helm file, and I'm starting to try to come up with some best practices because, some of us now have more experience with Helm file than others. And so we're looking at things like, is it like the cleanup on fail flag, for example, is it a best practice to have that on, or just leave it as the default of false?
Yeah. Well, so I would be weary about that in production, and I'd be recommending it perhaps in staging, but it depends. Maybe not on all staging environments. Maybe just on your demo or preview type environments. This just came up today, so let me explain a little bit more. So, as we know with Helm, if you do an upgrade, it will bail on you if the previous release has failed. So then you can't move forward. And if you add the force flag, for example, then it will uninstall that failed release and then reinstall. But that might be pretty disruptive if you're running in a production environment, especially since a failed upgrade or a failed deployment doesn't mean a dysfunctional service. It just means the service is in an unknown state. So this is why you might not want to clean up resources if it'll help you debug what went wrong. However, in a staging environment or preview environments where you're deploying frequently and you don't want your builds to constantly fail, especially when you're developing, especially when you know things might be breaking and unstable, then I like the force flag and possibly the cleanup flag then to just keep things humming along.
Even in staging, I would totally agree with that for dev. But in staging, wouldn't you want to have my thought process for staging is all right, I want to have whatever production has now, and then run the exact same command that you're going to run in production and see what happens.
Yeah, so sorry, we're just overloading the term staging like every company does. Staging in your context is like a pre-production.
Yeah.
We have something so staging to us is an account stage where you will have environments with different designations. So one designation would be pre-production, and pre-production should be almost identical to production. But then you have unlimited staging or preview environments. Those are also running in staging, our staging account, but they have a different designation.
Okay.
So it's just that different companies use these terms differently, and so we're saying the same thing, we're just using different terms.
Hey Eric, can you correct me if I'm wrong, but Helm will still deploy to a failed deploy if there were previous deployments that passed, right?
My understanding, if the most recent deploy failed, the upgrade will fail unless you have the force flag but I don't want to claim expertise on that. I've been using Helm file so long, so Helm file kind of redefines some of those behaviors, and if you use the force flag on Helm file, then the first thing it does is an uninstall of the release if it is failed to ensure that this successfully installs. But the raw Helm functionality, maybe. If somebody knows for sure, please chime in.
I'm almost positive that's the case, just because I have instances where the initial deploy will fail, and then I won't be able to deploy to that again until I do like a Helm delete purge.
Right.
I will have long running deployments that will fail, and then running like another deploy does work, and I don't have to like delete that Helm.
So you're saying when there are multiple Helm releases, you're able to do it, but if there's only one Helm release, you can't?
So for a particular release, if it's been deployed successfully before and the most continue deploying as long as it was successful before. Does that make sense?
Okay, that's worth that might be the case.
I believe, at least in my case, I haven't seen that problem. But definitely, if it's the initial deploy of a release and it's never been deployed before and it fails, you cannot redeploy it until you purge that release.
Yeah. So maybe what we're thinking, you see my screen here, and I think it's the atomic flag that helps with this magic here.
Ah, that's nice.
By the way, Brian, I shared just before you joined, I think, the resolution to your issue with the random node reboots.
Oh, yeah. Yeah, just for those that ever have to run into this issue, check the EC2 system logs. We'll have all of your kernel logs versus checking on the box. Or I guess ship it yourself. But I think just if you're on AWS, they already ship it for you. So you might as well just use theirs.
Yeah. Cool. Any other questions or insights here?
I need to come up with a demo of infrastructure as code using just my local computer.
So self-contained, like a demo?
Yeah. Any ideas? There's like, I could do Vagrant with, spinning up a couple of virtual machines. I love to use Terraform because that's what I use, for real infrastructure as code. And so like, if I'm just showing code, I'm going to show Terraform code. But I need to be able to do a demo of like, hey, look at me spinning up actual infrastructure, but I won't have access to an AWS account or anything because multiple people are going to do this.
I see what you're saying. Well, does it specifically need, sorry, Siri woke up here. Does it specifically need to demo AWS functionality or demo Terraform?
Just IAC, any kind of IAC.
Okay. Well, one food for thought, if it jogs your memory, because I know you're working on Dad's Garage, your equivalent of Geodesic. One of the prototypes I did here, it was just a, I think it was a, yeah. So I did a prototype of working with Minikube, but then it also works with Docker for Mac, and I assume most of your company would have Docker for Mac installed, right? No?
You would think.
Okay, well, okay, maybe then the value of what I'm saying is moot, but what I was going to say is if you're running Docker for Mac, or probably Docker for Windows too, you can just check off this box to enable Kubernetes.
That's not a bad idea, though.
And then
you could do like
Docker.
you could do Terraform code that just spins up Docker containers.
Yeah.
You know, because all I really care about is showing, like, you know, look, here is code that spun up, you know, it spun up Ubuntu with this exact version that I spun up with this exact amount of memory and CPU power that I told it to spin up, you know, and it spun up 3 of them because I told it to spin up 3 of them, you know, and now I'm going to kill them all with 1 command.
Yeah.
That's infrastructure as code, right? They're Docker containers instead of virtual machines, but the concept is the same.
Yep. And faster demos, lighter weight. And as you know, there's a Docker provider. So you can also skip what I said about Kubernetes, and you could just do plain vanilla Docker as well.
Can you provide the context of this demo? Is it like a lunch and learn for your coworkers?
It's for an intro to DevSecOps class. So we've got a section on infrastructure as code, and the customer wants a live demo of infrastructure as code.
So this demo does include AWS, but I did a talk on using Terraform to deploy a simple web API on a scaling group in AWS, and then do a blue-green deployment of that.
That's kind of fun.
Yeah, it's open source. I can send it to you, but it does require an AWS account. But I actually was going to do this for my coworkers and provide them, just create like a dummy AWS account, provide them the credentials, and then just ask them to do the Terraform destroy after. So you could technically do that. I guess it depends on the size of your class.
Yeah, that gives me some ideas. Like I could do something like, you know, given the way that you guys currently handle your infrastructure, how would you handle, you know, doing a OS version upgrade? Oh, well, you know, we'd have to SSH into each and every one of them and, you know, apply all the commands and shepherd them through, you know, the whole pets versus cattle thing.
Mm-hmm.
Versus I could be like, oh, I'm going to change this variable and then redeploy. That's a good idea. I like that.
Well, I did also, which was really cool too, when I did, or people thought was really cool when I did my demo, was I deployed it to 2 different regions and 2 different environments, all with like the same Terraform. And it was just a switch of a variable. And when I did that demo, everybody appreciated that.
Yeah, that's a good idea.
Now you have identical environments, but one is staging and one is prod. The prod one might have, you know, T2 X larges. The staging one might have T2 micros. Other than that, everything else is running the same.
Sweet.
Yeah, that's cool. That reminds me of one of the posts one of our customers shared with us, only because it was a nice summary of many people's experience with Terraform. Like when you start to where you are today, like when you start with a small little project, and then you realize you need a staging environment, so you clone that code in the same project, and now you have 2 environments. But you know, any change is in the blast radius of all of those. So then you move to having separate projects and all of that stuff. Let me find that link in the Terraform channel. That was the first time I heard of the term a teralith for a Terraform monolith.
A teralith, I love it.
Yeah, isn't that a perfect description of it?
Yeah, everyone knows what you mean if they've ever dealt with one. So.
Yeah.
Speaking of teraliths, I was thinking about the way that you had showed the way you do the Terraform infrastructure for your clients with like each client gets a GitHub organization, and then there is what's under the like, do you have, is it just one big Terraform apply or whatever for like the whole thing, or is it broken out?
Yeah, it's all decomposed. So basically, our thing is that we've been using so here's like an organization, and then each AWS account represents basically a dedicated application. And then, so therefore, each one of those has a repository. But then you go into each one of these repositories, and then they have software, just like your applications have software. But your applications, what do? They pin at library versions. So that's what we do here. So you want to run the same versions of software in all these environments, all these AWS accounts, and we do that just by pinning like to a remote module. So here we pin to a remote module. So when we make changes to this directory, that triggers a plan and apply workflow with Atlantis.
There's a plan applied just for the CloudTrail directory or whatever,
Exactly.
not for the whole staging.cathix.io.
Exactly. So basically, you open pull requests that modify any one of these projects, and that will trigger. You can modify multiple projects at the same time. There's no
we'll
harm.
Do multiple applies to do that.
Exactly. Well, no.
Multiple plans.
Yeah, multiple plans, multiple applies to do that, but all in the same pull request and all automatic.
Sure. Right. Okay. What does that look like? Does Atlantis, when you submit a pull request, does Atlantis say, this affected 3 Terraform projects, and here's the plans for all 3 of them? Is that what it does?
Yeah. So the pull request was opened automatically, or was opened manually by a human, a developer. Then the plan was kicked off automatically, and then we see this output here. This happens to be output from Helm file, right? Not Terraform. But because we use Atlantis for both Helm file and Terraform. And then we see this is what's going to change. And then somebody approved it. And then we can surgically target what part of that we want to apply. Or we can just say Atlantis apply, and it'll apply all changes.
Gotcha.
So one thing to note about Atlantis, which is really nice, is that it locks that project that you're in. So 2 developers can't be trying to modify, in this case, Cube system at the same time. Because otherwise those those applies will be undoing each other's changes, and they'll be at war with each other. Cool. So Brian, any interesting projects you're working on?
I'm starting my Prometheus initiative.
Oh, nice. Very cool. Very cool. Are you going to take a federated approach, or?
As in like a remote storage? I forgot.
No. So basically, you have a centralized Prometheus, but then each cluster runs its own Prometheus, and the centralized Prometheus scrapes the other ones.
Oh, that's possible. I'm not sure yet. I actually just started yesterday looking at the Helm file for it. But yeah, I'll be honest, I'm not super familiar with Prometheus. It's just I know that it's a lot more lightweight than what we're currently running, which is SysDig. SysDig is third party, but takes up like 30% of our CPU on an R4 2X large, and is also the cause of the node reboots. And it's just, for a monitoring tool, it's just asking for too much. It also is memory intensive as well.
Yeah.
So Prometheus obviously is on the other side of that spectrum where it is not a resource hog, which is why
Yeah.
we're.
I mean, yeah, Sysdig, it takes a brute force method to monitoring, right? It looks at like a packet inspection and everything happening on that box. I guess it's a testament to how fast CPUs have come and how cheap memory is that they're able to get away with doing that.
Yeah.
But it's still a problem when you're doing things like you are saying now.
Yep. But yeah, have you guys gone the federated approach? What would you say about that?
So we're starting a project in the next month or so, and with a new customer that's going to be doing federated Prometheus. The reason for that case is they're going to be running like dozens or more single tenant dedicated environments of their stack for customers. It's basically an enterprise SaaS. So, having dozens and dozens of Prometheuses and Grafanas would just be too much noise and too hard to centrally manage. Also, scaling that architecture, if you only had central Prometheus, would be dangerous because at some point you're going to hit a tipping point and it's just not going to handle it. So with the federated approach, basically you can run Prometheus, because Prometheus is basically a time series database in addition to its ability to harvest these metrics. Now, it can use like a real-time series database like InfluxDB or Postgres with time series DB or whatever support and a bunch of others. But the simplest way, I think, is just to think about Prometheus basically as a database, even though it can offload that. So then what you can do is you can run smaller instances of Prometheus on each cluster with a shorter retention period. So you can still get real-time data in, but you don't need to run massive deployments of Prometheus, which can get expensive because running Prometheus with less than 12, 15 gigs allocated to the main Prometheus operator is required for any sort of retention more than like a week or two. So in the federated model, basically you set up like on a shared services cluster, what we call Corp, one Prometheus instance that then scrapes the other ones. And it can do that at its own pace, and you can also downscale the precision in the process of doing that if you need to.
Nice.
Plus, if you do need absolute real time, you can still have Grafana running on all the clusters, and you can have like real time updates on those environments. So, different ways of looking at it.
Do you guys use the remote storage?
We don't. So it's it's been in our backlog of things to solve, and there are a few options of it. The one that keeps coming up is Thanos, but when you look at the architecture, it suddenly increases the scope of what you got to manage, right? And when it's your monitoring system, it's really important that it's up, so I understand and appreciate the need to have a reliable back end. But also, the more moving pieces, the bigger the problem is if something goes down. And then what monitors the monitoring system and all these things. So we've gotten away with using EFS, and as scary as that sounds, it's actually less scary these days because EFS has basically POSIX compatibility. And you can reserve IOPS on EFS. So the problems that we've had with Prometheus have been related to IOPS. And then we just bumped up, you pay to play, and it's not that much more to pay to play compared to engineering time. So we just bumped up the IOPS and all our problems went away. The other option I think Andrew's brought up before is that you can also just allocate more storage and then you get more IOPS.
Which is great because it leaves it burstable.
Yeah.
It just gives you more credits. So if you still have burstable IOPS, you don't need that higher baseline, but the number of credits you're getting is not high enough given the amount of data you have. just store a bunch of random data, and the amount of money you pay in that IOPS.
Your signal's pretty bad, Andrew, or at least for me. Is anyone else hearing the feedback?
A little bit, yeah.
Yeah.
So would I be able to use, so you know how I have a ephemeral cluster type situation. Would I be able to use EFS with an EKS cluster?
Oh, yeah.
And
Yeah,
then
totally.
have a new EKS cluster that ties back into the same EFS?
Yep.
Yeah. Yep. You could have a static EFS file system, for example, and just keep reusing that in your your ephemeral EKS clusters.
Awesome. Yeah.
What's really nice about EFS is it does not suffer from the same limitations of being EFS is cross availability zone
Yes.
Mhm.
versus EBS, which is not.
Yeah.
So the issue people run into frequently when doing persistent volume storage in Kubernetes is, let's say you spin up Jenkins and you have a 3-node cluster across 3 availability zones because you like high availability. Woohoo! Jenkins spins up in US East 1A, and then for some reason Jenkins restarts, and next time Jenkins spins up in US East 1B, but that EBS volume is in 1A still. Jenkins can't spin up because it can't connect to the EBS volume.
Yep.
So you're hosed.
Yep.
EFS does not have that problem.
Yep. In fact, we've changed the default, I forget what the term is, the default storage
class.
Yeah, storage class for Kubernetes to EKS, and make it explicit if you want EBS, like for certain situations. But that's worked out really well for us. Plus, it simplifies backups too, because you can just set up AWS backup on your EFS file system. You don't have to worry about backups of every single volume provisioned by Kubernetes. So it's a lot easier just to back up the whole file system.
We don't do that because it would be backing up random crap that we don't need.
Mm-hmm.
But you can definitely do that.
Yep. And if you use the shameless plug, if you use the Cloud Posse or EFS module, it supports AWS backups, I believe.
There you go.
Cool. That's good to know. Thank you, guys. I probably wouldn't have looked the route of EFS.
It sounds like not the right thing to do, but we're running it right now with, so far we have maybe 3 months of retention in it, and it's fine. Obviously, we have to wait and see how it goes up to 6 months, but I don't see any problems right now. As soon as we address the memory issues of Prometheus.
We've been running for way over 6 months,
okay.
and we're fine.
And what's
it's about IOPS, right? As long as your IOPS handle, you know, if you are in production and you're Amazon, of course you shouldn't use EFS or, you know, your Google or whoever. That's dumb. But if you're a small, you know, if your traffic is small, go for it.
Yeah.
And don't listen to all the people saying, "Oh, you should never run Postgres on EFS because it's the NFS." It's fine. Don't worry about it. Try it, and if it causes issues, then figure out something else. Don't add complexity right off the bat until you have tried the less complex option and determined that it's not a good option.
Yeah, I think that's a good way of putting it.
Are you guys using the CSI driver for EFS?
I'm using EFS Provisioner, whatever that's using.
Yeah.
I don't know.
Yeah.
There's a tool called EFS Provisioner that you deploy to your Kubernetes cluster that just provisions persistent volumes for you given persistent volume claims, and it works great.
I just posted what I was looking at in the office hours channel. Okay, so you guys are using EFS Provisioner.
EFS Provisioner.
Okay, cool.
Yeah, I think we have a Helm file for it too.
Thank you. Good to know.
Yeah, EFS Provisioner. Here's the Helm file that we've used.
It works great. We've been on it over a year. No problems.
And so you guys are testing out Kubernetes Federation, Eric?
No, we have not gone the federation route for Kubernetes. Just for clarification, when I was mentioning federation, that was for Prometheus, which is unrelated.
Ah, I'll have to look into that for Prometheus.
Yeah.
Pro tip with EFS: if you're going to go into GovCloud for any reason, use GovCloud West. GovCloud East does not have EFS. We made that mistake,
Oops.
and it has cost us.
Wow. Oh, Brian, by the way, where I first pretty much learned about what this looks like for the federated Prometheus is from your pal Corey Gale over at GumGum. So they can definitely shed some light. They're not doing it under Kubernetes. They're doing it like on bare metal, but they can tell you about why they did it.
Yeah, and I know that they just started that Prometheus initiative like maybe half a year ago.
Yeah.
Even that, which is really cool.
Yeah.
Cool.
All right. Cool. So let's see. Any other parting thoughts here before we start wrapping things up for today? Any other interesting news announcements you guys have seen on Hacker News?
Don't use apparently friggin' what's it called? WhatsApp.
Yeah.
If you're Jeff Bezos, don't use WhatsApp.
Yeah. That did not sound too good. Also, I thought Apple backups were encrypted, but now they're saying they're not encrypted?
I have started using Keybase heavily, and I'm absolutely in love.
Keybase is awesome.
But Keybase, I mean, that's great for chat and validation or whatever, and maybe with AWS account creations and whatnot, but it's not going to help you back up your iPhone, right?
You use file communications from it.
I don't have an iPhone.
Yeah, I'm using Android. So,
okay.
I mean,
yeah,
Keybase has file storage, and it even has encrypted Git repositories.
I saw that. Yeah. That's interesting.
And underrated are their exploding messages if you are sending secrets.
That's a good tip too.
Exploding messages?
Like Mission Impossible?
They literally explode in the UI.
I haven't seen that.
So
How does that work?
Set a time limit on your message.
Oh yeah, sure enough.
That's cool.
That's cool. I've never used that. I don't really use it for the chat because none of my friends are on it. Poor me.
It's what we use in-house to send like some of our secrets.
Yeah, it's one of our best practices when we start with a new customer to always recommend that they set up a team under Keybase for those situations where you need to share secrets that don't fit into like the best practices of using a password manager or the best practices of using like a HashiCorp Vault.
Just kind of a one-off.
Yeah, for the one-off things, right? Because a lot of these other tools don't support direct sharing of secrets to individuals in an encrypted fashion.
Just put your passwords in Slack. What could go wrong?
Seriously.
I
Cool.
cannot
But-
get access. I cannot get this stupid Docker provider to work. Whatever. Forget. I said.
All right, everyone. Well, on that note, I think we'll let it be. We're going to wrap up office hours here. And thanks again for sharing everything. I always learn so much from these calls. Recording of this call is going to be posted in the office hours channel. See you guys next week, same time, same place.
Thank you.
Thanks, guys.
Thanks, Eric.